Hello, folks, and this is the title that I'd like uh, to look at, and because this statement can be on your exam, so you need to critically appraise this. That is it the user that is to be blamed, or is it the instrument that is to be blamed? So you can see that as you are looking at the user, it is going to be the one who is misused it. So you need to be also look at this role of arbitrage, minimum and maximum values, and then effect of these factors, and more will be effect of these factors: exercise price, time to expiration, risk-free rate, volatility on option price will be done at chapter 5 as well. And then I can see from 3 to 1 you have a fairly good understanding of European and American options, the differences. And then put call parity is not an esoteric theory, it is fair applied all the time, and you'll see at different places. And these are the symbols that you have to be familiar with, and you can see call and put options depend on the same set of variables. And then a computation of risk-free rate is done when you are given T-bill bid discount rate. So this is the rate, therefore bid rate is higher than ask rate, but bid price is lower than ask price. So you find out the average T-bill, and after that you plug it in this formula, where this part is the holding period return, and you get the price, and after you pay the price, it is the ending value minus beginning value divided by the beginning value to find the return. But this is in continuous time, that's why it is to the power 365 by 7, and the risk-free rate is 4.57. And then maximum value, minimum value of the call is obviously this one is on the formula value. So at the beginning it is 0, that is which is the horizontal axis, and then it is a 45-degree line as a sub-zero x. And then the concept of time value will be clear in a graph. I'll show you that. And then effective time to expiration, as you can see, higher time to expiration means more call value. So T2 is greater than T1, and therefore T2 based on T2 will be higher than T1. And deep in the money and out of the money, the time value of money is is lower, but deep out of the money it is the least, and time value is maximized when it is at the money. So we'll show you with the graph, and I will show you the table about effects of exercise price. And then this question comes on that when do you exercise? You can exercise American call as close to X dividend rate, because if you do this after that, you lose out the dividend. And then the table here is the exercise price, and you can see current stock price is 125.94. So at the money is 125 strike. And for call, as you have more and more exercise price, the value is less and less. And for the put, it is more and more the exercise price value is more, because you're selling at higher and higher price, and this is you are buying at higher and higher price for call. So you can see it also that these are going to be higher across the rows and across the column I meant. And then you see the reason that time to expiration is positive for both call and put. And then you have this time value, and as I said before that at the money most time value, so these numbers are highest among the all three rows. This row, middle row, is highest. And then when you are in the money like this, this is for call option, so therefore when you are in the money mean 120, then your intrinsic value is positive, very high, but then you see time value of money is higher. And then when you have add the money, this is the highest time value of money, but your intrinsic value is smaller, and out of the money it is 0. So what is the upshot of this is that at the money, your time value of money is maximum. Put call parity is this equation here, which is in English is long stock plus long put is equal to long call and long bond. And then you can create synthetic long stock, synthetic long put, synthetic long call, synthetic long bond, but just by rearranging the equation. So synthetic long stock would be long call plus long bond minus long put. Synthetic long put would be long call plus long bond minus long stock, and so forth. And the picture tells you who are the players in here: call, put, stocks, and bonds. And why do we say long put call parity? Left hand side of the equation is long stock and long put is equal in cost to long call and long bond, which is on the right hand side. The reason being that they deliver the same output. Therefore, anything that delivers the same output has to cost the same. And then we'll talk more on interest rates and stock volatility, the impact on option pricing in chapter 5. Now the picture wise, you can see the lowest formula value is 0 and highest is this one, ST minus X. But then we say that this is the true option price, and they are similar. The true option price and the formula value are similar at deep out of the money, and they're similar at deep in the money. It is less divergence in here and less divergence here, but maximum divergence is at the money. That's why we say at the money, time value of money is maximum. And then again, this is time value of money, and then you can see intrinsic values like this, because for a put option, higher strike gives you more value intrinsically, but at the money, they would deliver most time value of money, as it was stated earlier. And then put option is a downward sloping curve. And so what we now have are these slides that you need to focus, but I also say that make sure that you do the suggested problems and consult the solutions. And one of the suggested problem I would like to draw your attention to is question 26 in chapter 3. Alright folks, I'll talk to you next week. So until then, take care.